Comcast is one of the platinum partners for Mile High Workshop. So they're the ones who are paying for the food and drinks today. But for the happy hour over here, I hope you guys are more than just happy at the happy hour. It's been a wonderful set of talks going from academics to people who are rolling up their sleeves and showing how they're implementing stuff and showing the tools. So I think it's a great set of talks. So we enjoy participating in this. Speaking of that, today we're going to talk about a little bit about Comcast's participation in some of the standards and in some of its reasons and when it gets out of it. And Comcast does participate in a lot of standards, going from video to data to ML to AI. And so there are a lot of people involved in that. We get, I guess from the standards perspectives, one thing we get is the ability to bring this back into our internal companies and let them know what's going on out there. So when they're trying to solve their implementations and stuff, they are aware of some of the standards out there. At the same time, it's also a feedback cycle where we're listening to the people inside, understanding their problems, sometimes understanding how they solve their problems, and bringing that back up to the standards part over there. So we see that as a lot of value and feedback on that. And Comcast, I think, has a unique perspective in all this because it's a fairly big three-part company. It's not just the cable portion of this. We do have our kind of cousin companies, which is NBCU and Sky. So when we do see perspectives and issues on this, we're not just looking to see what's the immediate, how to solve this in just the local context. We're looking at it from an end-to-end perspective where, you know, if from the NBCU perspective, you know, they're always looking at how to preserve creative intent or how to display HDR properly, and all the way down to where Sky's looking at live sporting events, or something that especially comes up in some of the stuff we're doing is international aspects to this. So we feel that we get a lot of value in standards, but we also feel that we put a lot of value in there as well. So anyways, we are going to not cover every single standard over here. So we are going to look at some of the activities we're doing in SCTE, which is the Society of Cable and Television Engineers. And it is a home to several well-used standards out there, ranging from advertising to video to adaptive streaming types of applications, which we've been listening over here. So we'll give you a quick overview of some of that. So what I'd like to do is bring to the stage Dr. Stuart Kukowski, who's part of the CTS group and who also works in the Working Group 5 group in SCTE, which is advertising in there. And just to let you know that Working Group 5 is a 3-time Emmy Award winner from its specs. I guess I'll just hand this off to Stuart now.
All right, here we go. Yeah, so thank you, Yasser. As Yasser mentioned, there's two sides of the standards, right? We participate in the standards bodies. As I mentioned, I'm in DVS, specifically digital program insertion, which has to do with blackouts, regionalization, and advertising, those kind of things. And so we participate in writing those, but then also consuming it. And so I just want to show you some examples today of how that give and take takes place at Comcast. Again, I'm from Comcast Technology Solutions, so we have some of the external-facing technologies out of Comcast that we sell around the community. So the first standard is SCTE 224. Maybe it's one you haven't heard of as much, but we'll talk about it today in context. And the driver behind that, the examples that we're going to use today, are around regional blackouts, oftentimes around sports, although people would also use it for regionalization that we'll see in a couple other formats that people are starting to use now that they have newer capabilities. There's also ad insertion that runs the gamut from describing ads to also differentiating what one operator can do versus another operator. We'll talk about those examples. There's also device restrictions. A lot of people are surprised to understand that, or maybe they're not, but a lot of the old content that was acquired decades ago, black and white content can't be run on certain devices. A few years ago in the United States, we had the NFL games that were restricted to Verizon phones, right, that era. And so there's device restrictions as well. And then there's also linear schedule, which allows you to schedules out ahead of time, which allows you to tweak and customize and make very accurate your electronic program guides and things like that. All of that come from the standards that we're going to talk about that come from the Digital Program Insertion Group. This is kind of a busy slide, but the idea is that you see it starts at the CDN there on the left, and then the video flows in, and you see the ecosystem around it with many of the different standards identified. This is for traditional, more traditional, I would say, MVPD. Let me go to this one. It's a little cleaner so you can see it a little better maybe. This has the CDN with the video flowing in. That's where the SCTE 35 standard comes into play, and we'll talk about these in more detail. But you also see some of 130 for the advertising piece to the POIS, and then also to the ad decisioning service you see on the left there. You also see SCTE 250 that we'll talk about, and 224. So there's lots of standards in this ecosystem that all come together to make the scenarios we're going to talk about possible. And then you also see at the bottom there the SCTE 224 coming in from the content provider, which is out of band, which is a key piece that we're going to talk about. And so to give you a little motivation for how all these standards come together, this is a blackout scenario from one of our syndication partners at Comcast. In Demand is a company that provides the sports content to many of you. They do it for NHL, NBA, sorry, right letters, wrong order. MLS, and also the MLB. And so they have the 24 channels, and for this syndication partner, they have 29 DMAs or regions across the country that they have to provision this content, send that out. So if you do the math, those 24 channels sent out to the 29 DMAs is just short of 700 different variations, right? If you have redundancy across your ecosystem, now you're up to 1,392 different feeds you have to manage, transcode, do all the penalty that comes with moving that around. And using SCTE 224 and SCTE 35, and also 250 that we'll see in a minute, you can dramatically reduce that, right? I can centrally manage that content as we saw in the previous slides using a linear stream stitcher or a manifest manipulator. I could greatly reduce the amount of work that I'm trying to do in delivering this content, right? And so keep that in mind as kind of the motivation for us at Comcast of how we tie all these standards together. And so to do that, let's get into the standards a little bit more. So the first one is SCTE 35. This again is kind of where the frame accurate insertion points are within the video. For you younger folks out there, that's a representation of a video, right? That's like, you know, the old stream kind of stuff there. Anyway, we have accurate points within the frames in the video. And so we have these points identified, right? And so now they're frame accurate. A lot of you say, well, this is where I stop. I stop at SCTE 35. I can cram a ton in there, right? Some of you are guilty of SCTE 35s that are across multiple frames, right? You're trying to cram hundreds of zip codes and things into there, right? The main goal of 35 should be just to identify these marks within the stream, and then you use the other standards outside of that to do more fancy things, one of which is SCTE 224. So this is the event scheduling and notification interface. As we saw in the charts, one of the big keys of this is it's out of band. So I can carry a ton of information and not have to cram it into that SCTE 35 that's inside my video that's taking up frame space, right? So I can do quite a few things. I can identify audiences, which you'll see is the key to this whole construct. In the standard today, we have over 40 different audience types, so it could be zip codes, DMAs, lat longs, device types, all those kinds of things, and we have over 40 actions as well. So I can combine these audiences with actions, which gives me a huge amount of capability. And then the last one, the less known probably of the three, but the one that got 2 of the Emmys that Yasser talked about, is the ESAM standard. A lot of you might remember ESAM IO1 or IO3. That has since transitioned over to SCTE, and when it went to SCTE, it got branded number-wise to SCTE 250. It's a much smaller document now than if you're used to the old ones that were huge. But this is really the communication channel between that signal acquisition system, the part that's seeing the video, and the part that you need to make a decision from. So that decisioning could be on ads, a POIS, or it could be a 224 decision engine, and we'll see how that works here. So the key then is the SCTE 224 objects. There's a media, which is a container for all of the activities that you want to do during, like on a channel or in a show. Then you have media points. These are points within there that you want to make a decision. And those carry with them a policy, which is a container for viewing policies. And viewing policies is where everything comes together. That audience and action gets tied together. And then audiences obviously characterize your audience. So let's look at this. Again, if I see an SCTE 35 at the start of a show, the encoder or packager or whatever sees that, the manifest manipulator, calls the decisionaire and says, hey, I just saw this signal, what do you want me to do? It matches it against a media point using that 35 marker. So now we have frame accurate point in time, and now we have this out-of-band container which we can put a lot of information in. And so then it could also match at the end of the show or the end of the break or something like that. So again, that start gets triggered to a policy and a viewing policy, and then this is where it really comes together. So for example, let's say this is a map of the United States. You're televising some sporting event that's blacked out in a region kind of centered around Denver here where we are today. So I'm sending it out, and the encoder says, hey, I have this stream. I just saw the start of this show. What do I do for this region, right? The Northwest, the East, or the Southwest. And it plays the video as it is, no changes. But in this Denver region, it gets blacked out, as reflected there on the left, because it's in that audience, and the action for that audience is to black out the content. So I'll take that same construct and expand it. I might have one that plays the video at the top, plays as it's being fed. Maybe there's a regionalized game represented by the green color, and that gets stitched in, and so it says at the start of the game, you're in a region that needs to pick up a different game. Let me switch you over to another game. Rather than having to have all these provisioned, you just build them on the fly with the signal acquisition system. I could also substitute in bot assets, right? Like the orange and blue reflected here, and I could stitch those together. Another example that we've had recently in Comcast is I have a live stream up top, right? And let's say I have a segmented show, and I want to play those segments in different orders, right? I can ship those to you ahead of time, have them on the CDN, and then the manifest manipulator can pick off those different segments and stitch that together. So you, at the end of it, let's say this is a 30-minute show, you have the same segments at the end of the 30 minutes, but I maybe showed you one that's more in your area at the beginning of the show rather than at the end. So I can reorder that, all again being done with SCTE 35 in the video and 224 out of the video. And so we also talked about advertising. This is kind of like the exciting new area, I would say, for this body of standards or this family of standards. And so one example here is, now that I have this audience action pairing, I could actually set up an audience where it's my partner, right? So if I'm a content provider and I'm shipping this video to Comcast, Cox, Charter, somebody like that, maybe I have an agreement with Comcast, right? And so Comcast is allowed to replace this third ad, and so they can do that. But for the other ones, they don't have the same agreement. I don't want them to replace the ad. They have to play the baked-in ad. I could provide that same action content pair just by saying, if your audience is Comcast and a different audience is Charter, they have different actions, right? And then furthermore, because it's out of band again, and I'm not constrained by capacity, I could put even more information in those media points around the metadata. So I could add inclusion rules, right? That's hard to fit into a 35 marker. I could also add exclusion rules. So maybe I know as a programmer, I'm going to play a Coca-Cola ad, so when it gets to your ad that's targetable or replaceable, I give you restrictions that say don't play a Pepsi ad because I just played a Coke ad, right? I can do all these kinds of things because it's out of band. And again, it's frame accurate because it's triggered by a 35 marker. I could also make all three of them addressable. I could start to include things like scene-based recommendations. So I know right before we cut to a commercial, there was a beach scene with a truck driving on the beach, so maybe you show a truck ad or something like that, right? Sky's the limit as to what we can embed in these out-of-band metadata fields. So there's some examples of there. Here's another example of kind of stitching them together again, back to the construct. I have a media point that triggers policies and then viewing policies, and in this case, the action says it's a targeted ad, for this MVPD1, the top audience that you see there. But I also have a second viewing policy there you see in the middle that says for this particular MVPD, not only is it targeted and replaceable by you, but you call Freewheel to go figure out what the replacement ad should be, because I've set up a campaign for you in Freewheel. But for my other MVPD, MVPD2, that I'm sending it to for that audience, the lower green box, it has a different viewing policy, and if you can see there, the action says GAM, right? You go to Google Ad Manager to go get your ad, because I've set up a different campaign with them, right? You could be that dynamic and that granular in your instructions. So, kind of to summarize the family again, we've contributed a lot as Comcast to these standards, but we also consume it and use it in our ecosystem as well. And so it's reduced equipment a lot, as you saw from the early diagrams and the numbers from our syndication partner that I used to reduce equipment, reduce workflows. And on the advertising side, we're just starting to scratch the surface on being able to differentiate ad breaks across operators, also be able to do different decisioning systems, ad inclusion rules, exclusion rules, those kinds of things. Maybe that's the cue to get off the stage, huh? Anyway, and again, because it's out of band metadata, you're not constrained by the packet size or the frame size, right? And so you can enrich that metadata almost limitlessly because it's out of band. So that's kind of summary of Working Group 5's standards around 35, 224, and 250. I'll invite Yasser back up. He's going to talk a little bit more about 214 and some of the other standards that we're involved in as well.
Stuart, do you want to take any questions before switching?
Okay. All right. Well, then, yeah, we can take questions if we want to do that. Go for it.
Yeah, so thanks for your presentation. So I have a bit of question that we were working with SCT standards. So you mentioned about the ESAM to SCT 250.
Yes.
So can you maybe elaborate a little bit what happened there? Because we looked at the Cable Lab ESAM and the SCT 250 and they were almost completely different.
Yeah, yes, they are. Yeah, it was kind of a conscious decision when they made that transition. IO3 was pretty popular, right? But it was also pretty extensive and pretty huge. And so when we went through the review as part of bringing it into SCTE, we did take out a bunch, and we also reformatted it a lot with some more efficiencies and things around those lines. Also, it's probably leaning more toward the IP world than some of the stuff that was previously in there. And so I would say we tried to make an effort to optimize it, greatly reduce it. It was 100 plus pages before, now it's less. But if there is feedback, things we missed or too much we pruned, we're always open, to feedback in the working groups.
No, it was just a little confusing because
Sure.
in the 250 it was like mentioned that Cable Labs was now ported to there, and then when we looked in the document, it was slightly different,
Yep.
different, quite different.
Yeah, it was quite different.
But that was just something to.
All right. But I'm glad you're looking at it and using it. That's a good thing. So, all right. Thank you.
All right.
Thank you, Stuart. Okay. Uh-huh. Okay. All right. Sounds good. So Stuart was talking about Working Group 5 stuff. I'm going to be talking about Working Group 7 stuff indirectly. That's dealing with some of the common themes we see in here, dealing with adaptive streaming, Dash, HLS. In SCTE Working Group 7, we have a suite of 214 documents in there. So you'll see SCTE 214-1, -2, -3. We just recently had 214-1 just revised, and this is dealing with MPD constraints in here. For some of this, this is assisting in our industry in the transition between a broadcast cable infrastructure into a unicast IP-based cable services, while also assisting in the transitioning in the back-end systems for supporting this. So unlike some other circumstances, we're not operating in a greenfield. We have to operate and make this transition as well as having existing back-end systems. And this thing is not just static, it's still being revised, so we'll be shifting this more towards incorporating ISO BMFF in the upstream of the network. So just to describe this diagram, over here in orange is kind of where our contribution feeds come in. It could be uncompressed, it could be compressed, and as you see, we do have SCTE documents in here. It goes through a transcoder, and then it gets fed to both the IP transcoder as well as the traditional QAM transcoder. And so the traditional one is the one that ends up on a cable set-top box in there, but the IP transcoder is the one that will get into multiple representations, goes through a packager, hits the origin, and then gets into the CDN distribution, and this is where the client players can grab their content from. And it's really two transitions in here. We're transitioning from a push model to a pull model, still using MPEG TS streams. As we move towards CMAF streams and low latency, we'll indirectly go back to a pull model in there. So while we're trying to do this, we're trying to maintain consistent features and services, so to make sure the customer experience as this stuff is changing is still kind of equivalent over there, and then also trying to provide this transition path towards CMAF via DVS 1603, which is our draft standard for low latency. So you see in this diagram, we have all the way from ingest to processing to CDNs to where it hits multiple devices, and in the bubbles are all the types of SCTE documents that read upon those areas. So let me step back a bit and talk about standards and specifications. In a number of talks, they basically said, here's a standard, and it's like if you printed it out, it would be this thick. So the standards are there to deal with multiple industries in there, but then you have other groups who are dealing with interoperability or applications that basically try to prune that out to the smaller parts of the standard which are more applicable to either the industry or to practical use. So these are groups like SCTE, but also ATSC, DVB, -IF, CTA, and they take different facets on this. Some of them is simplification, some of this is industry specific, but all these groups are trying to work together to develop a kind of cohesive part where, you know, certification is there, as well as other aspects. And an important thing on this is not just everyone's dealing with this separately. Everyone needs to communicate. So there is a lot of liaison traffic going between groups, and at least with all these existing groups there's a voice to direct this traffic. So in some of this, we actually go back to the main standard, and this is where some of the revisions come up as they start seeing new needs and stuff that are coming out from the industry. In practice, it may not be obvious where you see some of this stuff, but it does come up. So for instance, what I'm showing over here is something that was demoed in the ATSC booth at NAB, where they were showing audio description and how it goes through a broadcast. And some of the standard stuff behind that was basically starting from MPEG-2 transport, because a lot of contribution streams come in there, and trying to map that into dash roles and accessibility roles, which then could be put out on the broadcast and presented over there. You know, all this stuff could be done manually. What we're trying to do, in effect, is trying to create a workflow from that, so there's more automation. And then this slide's another case of a practice where we have an example of Atmos being put out in there. So you see the MPEG manifest in there, and you see the uses of supplemental properties, which also help to further identify the audio parts on this. So this stuff is coming up because we have operational considerations and transformations. So as I was repeating before, we need to reuse of existing content ingestion systems, signaling and notification systems, reduce the scaling demands that would happen. I mean, we're going from something that was kind of multicast to a unicast type of thing, all while still providing similar viewer experiences. So, just talking about 214 specs. So we're exercising new features in the new revisions. One of them is missing segments. How does that help? Well, as we're dealing with low latency and CMAF and live ingest scenarios, there are situations where the transcoder may have a source signal, and that source signal is not always dependent. And how do you deal with that? Well, you have to make sure you can deal with gaps, timeline interruptions, and stuff like that. So having some of the brands being put in helps out in that. Other parts in SATE, along with our specifications, we're dealing with schemas. So in case that we have to put in an attribute or supplemental property, there's actually a place to have a schema that adds those parts in there. Some of the other stuff we've been doing is adding in VVC codecs and HDR. Remember, it's a big company, so this stuff came in. So we added in support for VVC, and it already has support for AVC and HEVC. But it also includes support for HDR10 with Dolby Vision and HDR10 Plus in here. And this is one of my favorites. It's adding in new language identifiers. So among all the standards and specifications group, there's been an effort headed up by Mike to kind of try to move us all over to BCP 47, which is not another standard like saying, oh, we're moving from ISO 639-1, which is 2-character language codes, to -3, which is 3 characters, but BCP 47 is a little bit more encompassing, where it starts off with a root of the language tag that's still the same as ISO 69, but you use the shortest character on that, and then expands it to regional and dialects on that. So some cool things over here is with BCP 47, you can represent German, but as used in Austria. You can represent Serbian as used with a Latin script as used in Serbia. Or you can represent Spanish as ES 419, which is appropriate for the UN-defined Latin America and Caribbean region. So there's a lot of parts on that. But it's not a changeover to this. It actually incorporates that, because you can see at the base, you have DE, SR, ES. So in case you may identify it as that, but as ingesting it, you can still take it as a simple part, which helps out in the diversity of systems that are out there. So focus areas. Well, with this stuff, you can tackle small little problems, but you should really look at it in the context of larger types of areas. So I'm just pointing out some of the first areas that we are looking at. So area 1 is managing manifest size while adding features. So in order to do that, you can add in new types of features, but it may expand the manifest. So some of this may be trying to develop a one-to-one alignment between the adaptation set and the set of all media content segments, so you don't have multiple adaptation sets pointing towards the same content. You can design adaptation sets for optional features like HDR dynamic metadata. Some people have been trying to do multiple adaptation sets, but it is possible to use a single adaptation set where the player either recognizes the optional feature or not, and if it doesn't recognize it, it can still play the adaptation set, but at its base mode. The other one that people are encountering is some of the increase in manifest sides due to the audio pattern, where the duration segments may change a bit, but in a pattern. And so, there's talk about dealing with a mixed mode where you may have segment timeline, but the actual audio segments may deal with number. And so several people in all the groups are kind of discussing this. Another area is to reduce playout indecisions. So in the specs, in the 214 specs, we've added the use of using @selection priority, which is in the dash spec, to help disambiguate adaptation sets that may be viewed by the player as, this is the same value, so we're trying to set kind of a priority value in there. One of the things we did in SCTE was to add the use of media language defaults, which helps out when you start encountering things like ad insertion, that I might have a certain language that may be associated like English for MPDs or for the period, such that when I switch to an ad, I can still have a value, a determinate value to switch to, like English in there, or Spanish, depending on what the customer preferences are. So that helps out because not all ads have all the same options as the regular main program. Another part is helping clearing out ambiguity as guidelines for event expirations in there as well. Another area, and this is related to some of the stewards stuff, is taking the SCT35 events and flipping it into dash constructs. And as a plug for tomorrow's talk that I and Rafael are going to be talking about, this is related to it, but it's to help out with things like if I take an SCTE 35 message, how do I put it up into the manifest of a dash part? So you do things like epoch locking. You try to define clarity by saying this needs to be dispatched on an on-receive mode, and it helps prepare events for coming in. So, and also it anticipates that some of the SCT35 stuff may not come in through the signal itself. It may actually come in through 224 and 250 interfacing with the packager. So we're anticipating that these messages can come in more than one type of carriage. Another part, and I repeated myself in this before, but the automation of ingest workflow. We can manually put in some stuff, but really the key thing is to make the workflow from ingest to dash to presentation to even HLS be more automated. So if you see these two tables down here, these are mappings of what could come in as an MPEG-2 language descriptor and how they map into roles and accessibility. So for instance, I could identify primary audio, native audio, or also I could identify audio description in there as well. And in this case, you have things like BCP 47 parts to this. You can also identify language changes, no language, as well as language not known. So all this is to help out in the automation of the ingest workflow. So I'm going to move to the last slide and hand this over to Alex.
So the last area is low latency and low delay. Probably being the last person per. Which one of them works? Both. Okay. So being the last person before the drinks means that low latency and low delay is kind of important. So we've seen that practice shows it's possible. It's not easy, but possible to achieve broadcast equivalent latency in adaptive streaming. You can do it with low latency HLS, with low latency dash. You do want to use dash F live ingest, and you do want to use CMCD. We have this. We've seen this work. We've seen this work at scale. Now, we have a couple of challenges left. First of all, when you are tuning in, you have to wait till the end of the segment in any adaptive streaming system. So this means let's say you are using very small chunks. You are still using a 2-second IDR interval. You are waiting for 2 seconds to join. So this is something that becomes really important when you want to have very low latency. Second thing is unconditioned DI, which is you're going into an ad break in a place where you actually didn't have any stream conditioning. So you have no idea where you will land when you are exiting from this break, and if somebody happen to put an ADR frame there, or you have nothing to play till the next ADR in the stream you're returning to. And last but not the least, let's get something that has the latency equivalent. Okay, so latency closer to Twitter as opposed to latency closer to the satellite. So there are solutions that are able to achieve this, and in SCTE and now -IF, we started an activity that is trying to get to both very low latency and low delay capabilities, specifically in MPEG-. So this is something that is currently in the works, and we hope to get to both of these goals, and we hope that people here can join us. Thank you so much.